Hi everyone, this is my Module 6 Capstone project. The activity that I did for this project is called Glow Stick Chemistry, and this is just a little bit of an overview. The purpose is to get the students to go through a little bit of the scientific inquiry process, get them to hypothesize, analyze their data, make inferences. In this particular activity, I provided the question of how does temperature affect energy transformations, and then the students would then construct the hypothesis based upon information that I've already taught to them, as well as some background information that I provided. So the way that this activity aligns with STEM is taking their prior knowledge and giving them new information. I used glow sticks, and students have come into contact with glow sticks in different occasions, and they have different preconceptions about glow sticks. I had one student say, well, I've always put a glow stick in the freezer and I was told that that's going to make it last longer. I asked them, well, why is that? I don't know. Okay, well, let's find out. And so as we were doing the activity, it made a little bit more sense to them, and they gained some new information. It provides opportunities for interaction, so the students are going to interact with each other. They'll interact with me as I come around and ask them questions and kind of pick their brains a little bit about what they're seeing. It involves and engages the students. It's a hands-on activity. It's an activity that they get to actually see what's going on and see the kinetic molecular theory occurring and happening. And it's going to capture the students' interest. It's funny when I say, hey, we're going to use glow sticks, and like, oh, glow sticks, that's awesome. So, it's something simple and inexpensive that's easy to capture their interest. This activity would be a Level 1 confirmation inquiry activity based upon the Simplifying Inquiry Instruction article. Students confirm a principle through an activity in which the results are known in advance. So we already know that as temperature increases, the rate of the chemical reaction also increases. That's something that we've talked about. We've already talked about what is energy, what's an energy transformation, what is kinetic energy. So this activity is going to confirm all of that information that we've already talked about. So I give background information to the students. I give the students procedures on how to walk through the activity. The students will provide to me a hypothesis, as well as a data analysis and then conclusion questions. Alright, here's the setup here. So we have 3 beakers over here on the lab table. This one is hot, sitting on the hot plate. This one is cold, has ice cubes in it, and this is just room temperature. So at first, the students are asked to take the temperature of each of the 3 beakers. One is boiling, one should be ice cold, and the other should be room temperature. So the TI sensor was used in order to get those temperatures. Next, the students would take the glow sticks and then put them into each of the temperature waters here. And then, after they sit for a couple minutes, then we take the TI sensor and then we would get to see the luminescence that is coming off of the glow stick. So that's actually going to be measured in lux, as you can see over here. So we measure each one of the glow sticks and then compare the lux to see which one would be brighter and which temperature that was at. So you can see here all of the beakers sitting next to each other, and then another one of the light readings here. So then the students would take this data, they would look at the temperature, they would look at the lux reading, which is the luminescence or the brightness, and then they would make inferences. What happens as the temperature increases? Does the brightness also increase? Does it decrease? And then that will confirm what we had talked about the molecular theory of kinetic energy. And these are the references that I used: the Simplifying Inquiry Instruction and the National Research Council Successful K-12 STEM Education.